Have you noticed? Robots are everywhere. They're no longer confined to science fiction. They're busy cleaning our floors, mowing our lawns, and even navigating hospital hallways. These helpful machines are becoming increasingly integrated into our lives. It's an exciting time to be alive. But what makes these robots tick? How do they think and make decisions? It turns out there are different approaches to building robot brains. One approach, known as classical AI, aimed to create robots that could think like humans. However, this proved to be a very difficult challenge. Another approach, called behavior-based robotics, takes inspiration from the natural world. It turns out that simple creatures can do amazing things without complex thought processes. Behavior-based robotics aims to capture this elegant simplicity. Classical AI emerged in the mid-20th century. Scientists and engineers were excited about the potential of computers. They wondered, could we create machines that could think like us? Classical AI focused on symbolic reasoning, logic, and knowledge representation. The goal was to build robots that could understand the world through symbols and rules. These robots would then use this knowledge to plan complex actions and solve problems. While classical AI made significant progress in areas like chess playing, it struggled with the messiness of the real world. The real world is unpredictable. It's full of noise and uncertainty. Classical AI robots often faltered when faced with these challenges. As classical AI grappled with the complexities of the real world, a new approach emerged: behavior-based robotics. Instead of trying to replicate human-like thinking, behavior-based robotics drew inspiration from simpler organisms. Think about an ant colony. Individual ants have very simple behaviors, yet as a collective they build elaborate nests, find food, and defend their colony. How do they achieve such complexity with such simple minds? Behavior-based robotics recognizes that intelligence can emerge from the interaction of simple behaviors with the environment. Instead of relying on complex internal models, behavior-based robotics robots are designed to react directly to sensory input. They are equipped with sensors that allow them to perceive the world around them. Let's consider a simple example: a moth avoiding a predator. A classical AI approach might involve the moth building a detailed internal model of the predator. The moth would need to identify the predator, estimate its speed and trajectory, and then plan an escape route. A behavior-based robot, on the other hand, might rely on a simple rule: if something moves quickly towards me, fly in the opposite direction. This simple rule, coupled with the moth's ability to sense movement, allows it to effectively evade danger without complex calculations. This example highlights the key difference between classical AI and behavior-based robotics. Classical AI aims for high-level understanding and planning, while behavior-based robotics focuses on simple reactive behaviors that are directly coupled to the environment. Section 5. What is a behavior in robotics? In behavior-based robotics, a behavior is a simple, goal-directed action that a robot can perform. Behaviors are typically triggered by sensory input. They are the building blocks of a robot's actions. For example, a cleaning robot might have behaviors such as move forward, turn right, turn left, and avoid obstacles. These simple behaviors, when combined, allow the robot to navigate a room and clean the floor. Behaviors can be as simple or as complex as needed. A simple behavior might be triggered by a single sensor reading. A more complex behavior might involve the integration of multiple sensor readings and internal states. Section 6. Intelligence without complexity. One of the most fascinating aspects of behavior-based robotics is that it demonstrates how intelligent behavior can emerge from the interaction of simple components. Behavior-based robotics robots don't need to understand their environment in the same way humans do. Instead, they rely on a collection of simple behaviors that, when combined, allow them to achieve complex goals. This is analogous to the way a flock of birds can fly in formation without any individual bird knowing the overall plan. Each bird simply follows a few simple rules based on the position of its neighbors. This emergent intelligence is a key feature of behavior-based robotics. It allows robots to be robust, adaptable, and capable of operating in unpredictable environments. Section 7. Key features of behavior-based robots. Behavior-based robots share several key features. First, they rely on basic behaviors. BBR robots are built on a foundation of simple reactive behaviors. Next, autonomy is a critical aspect. BBR robots are designed to operate autonomously, without human intervention. They also excel in real-world interaction. BBR robots are designed to interact directly with the real world through sensors and actuators. Another key feature is robustness. The simple, distributed nature of BBR makes these robots robust to noise and uncertainty. Lastly, adaptability stands out. BBR robots can adapt to changing environments by modifying their behaviors. These features make BBR well suited for a wide range of applications, from domestic robots to industrial automation. Section 8. Designing behaviors from simple to sophisticated. Designing behaviors for a BBR robot is an iterative process. Engineers often start by identifying the robot's basic survival tasks. For example, a cleaning robot needs to be able to move around without bumping into things. Once the basic behaviors are in place, more complex behaviors can be added. These might include behaviors for navigating to specific locations, searching for objects, or interacting with humans. The design process often involves testing and refinement. Engineers observe the robot's behavior in different environments and make adjustments to its behaviors as needed. Section 9. A wandering robot. A simple behavior in action. Imagine a simple robot with 2 wheels, a few bump sensors and a single goal: to wander around a room without hitting anything. This robot might have 2 primary behaviors. First, move forward. This behavior is active when the robot's bump sensors are not triggered. Second, turn. This behavior is triggered when a bump sensor detects an obstacle. The robot might turn a random amount in either direction. These 2 simple behaviors, combined, allow the robot to explore its environment indefinitely while avoiding obstacles. This example demonstrates how even the simplest behaviors can lead to seemingly intelligent actions. Section 10. The future of behavior-based robotics. Simple solutions for complex challenges. Behavior-based robotics offers a powerful approach to building intelligent machines. By taking inspiration from the natural world, BBR embraces simplicity and robustness. As technology continues to advance, we can expect to see even more sophisticated and capable BBR robots. These robots will continue to transform our lives, from assisting with everyday tasks to tackling complex challenges in healthcare, manufacturing, and exploration. The future of robotics is bright, and behavior-based robotics will undoubtedly play a key role in shaping it. Remember, sometimes the simplest solutions are the most elegant and effective. Just ask an ant